Let's see if we can take the ideas from the last few videos and form a polynomial function in factored form of degree 3 whose zeros are -1, 0, and 4. And then let's see if we can sketch that graph knowing that it's going to be smooth and continuous. So f of x equals, well, we'll have some leading coefficient. I'll call that an arbitrary a. And then if I have a 0 of -1, in factored form, that would be x minus a -1. If I have a 0 of 0, that would be x minus 0. And if I have a 0 of 4, that would be x minus 4. Kind of simplifying some of those operations, I would have that arbitrary a. X minus a -1 will become x plus 1. X minus 0 could just be x. You could leave it as x minus 0. That wouldn't be incorrect. It's just not usual. And then x minus 4. Let me let a be 1. So if I let a just be 1, I'll probably write x first, and then x plus 1, and x minus 4. It really doesn't matter between which version you do and which order of your roots that you list them in their factored form. But now, let's kind of sketch this graph. I know I have a 0 at the origin when x equals 0. I have a 0 at -1. And I have a 0 at 4. And I know I don't have to lift my pencil if I'm a polynomial function. And if I let a be a positive 1, then remember from our parent functions, a cubic tends to be this snake curve like this. So I know I have to cross through -1. I also have to cross through 0, and I have to finally cross through 4. Now I'm getting a little bit ahead of our knowledge at this point because sometimes you don't always cross through, but for these we do. So our graph would look something like this. I didn't have to lift my pencil. Let's go to Desmos and look at this as well. So I'm just at desmos.com. And as you type in this function, remember I'm just letting a be 1 for now. I'm going to put x, it looks like a line because it's a linear function, and then x plus 1. Now it looks like a quadratic because it has degree 2. And as soon as I add this last factor of x minus 4, you can see that this very much looks like the graph that I sketched by hand with all the things that I know about polynomial functions so far.